Right. Today we are going to discuss problems on cam. All of you note down cam problem. Right. A cam with a minimum radius of 25 mm. A cam with a minimum radius of 25 mm, rotating clockwise at a uniform speed is to be designed to give a roll follower at the end of the valve rod mentioned described below. Once again repeat, all of you know done clearly. A cam with a minimum radius of 25 mm rotating clockwise at a uniform speed is to be designed to give a roller follower at the end of the valve rod mentioned described below. What are the film is mentioned? You can note down one by one. First one, to raise the valve through 50 mm during 120 degrees rotation of the cam. Second point, to keep the valve fully raised through next 30 degrees. Third point, the lower the valve during next 60 degrees. And fourth point, to keep the valve closed during the rest of the revolution, that is 150 degrees. Right, once again repeat, all of you note down. First point is to raise the valve through 50 mm during 120 degrees rotation of the cam. Second one, to keep the valve fully raised through the next 30 degrees. Third one, to lower the valve during next 60 degrees. And to keep the valve closed during the rest of the revolution, that is 150 degrees centigrade. Right. Next one, next line you can write next line. The diameter of the roller is 20 mm and the diameter of the camshaft is 25 mm. Next line, draw the profile of the cam when A bit. The line of the stroke of the valve rod, the line of the stroke of the valve rod passes through the axis of the camshaft. B bit. The line of the stroke of the offset, the line of the stroke is offset 15 mm from the axis of the camshaft. Next line. The displacement of the valve while being raised and lowered is to take place with a simple harmonic motion. Please stop. Determine the maximum acceleration of the valve rod when the camshaft is rotates at 100 rpm. By using this information, we can find draw diagrams. Right. Next line you can write. Draw the displacement, the velocity, and acceleration diagrams for one complete revolution of the camshaft. Right. Now write down what about given data is given. In given data, that value is given. Right. S is equal to 50 mm. You can convert in meters, 0.05 meters, and outstroke, right, that theta naught is equal to 120 degrees. You can convert in radians, and return stroke, that is theta r is equal to 60 degrees. You can convert in radians, and n is equal to 100 rpm is given. Right, this type of problem we are discussed in previously. Right, here since the valve is being raised and lowered with simple harmonic motion, therefore the displacement diagram, right, as shown in figure, the diagram is visible or not, you can check that one. Right, what are the procedure you follow this one? Right, this is completely drawn diagram on the notebook. Check that one. This is displacement diagram. What that fellow is want, first a bit profile of the cam when the line of stroke the valve rod passes through the axis of the camshaft. That is that fellow is want. For that, what you can do, right? You can follow some steps to draw displacement diagram by using this given data. Right, what is known as right, first one, draw a base circle with center O and radius equal to the minimum radius of the camshaft, that is 25 mm. Once again repeat, that is draw a base circle with center O, right, and radius equal to minimum radius of the camshaft, that is 25 mm. Right. Right, next point is draw a prime circle with center O and radius OA is minimum radius of cam plus half dia of the roller, that is nothing but 25 mm. 25 plus half into 20, that is equal to, you get dia of the roller is 35 mm will come. Next point is right, draw angle AOS is equal to 120 degrees to represent raising or outstroke of the wall, and SOT is equal to 30 degrees to represent dwell, and TOP, that is equal to 60 degrees to represent a lower or return stroke of the wall, right. Next one, fourth point, divide the angular displacement of the cam during a raising and lowering of the valve, that is angle AOS and TOP, into the same number of equal even parts in displacement diagram. Next one, fifth point is join the points 1, 2, 3, etc. with center O and produce the beyond of the prime circle is as shown in figure. Right. Next one, set of 1B, 2C, 3D, etc. equal to the displacement from displacement diagram. Join points A, B, C, and so on, N, P, A. The curve drawn through the points, we get right, which curve, pitch curve will come, right. Next one, what about eighth point, from the points A, B, C, and so on, N, P, draw circles radius equal to the radius of the roller. Next point, join the bottoms of the circle with a smooth curve as shown in figure. Right, this is required profile of the cam. Right. By using this procedure, you get a diagram is like this. By using this procedure, you get a diagram is like this. Right. Up to this, that fellow is want first part is A part is complete. Now we are going to discuss second part. This is the second part of the diagram. Right. What that fellow is given here. Profile of the cam when the line of stroke is offset 15 mm, 15 mm from the axis of the cam shaft. That is the condition. By using this condition, we can draw acceleration diagram. Right, here what steps are you can follow. First one is draw a base circle with center O and radius equal to 25 mm. Second point, draw a prime circle with center O and radius OA is 35 mm. Third point, draw an offset circle with center O and radius equal to 15 mm, 15. Fourth point, join OA from OA, draw the angular displacement of the cam, that is draw angles AOS is 120 degrees, SOT is 30 degrees, and TOP 60 degrees. Nothing but one is AOS nothing but outstroke, and SOT nothing but dwell, and TOP nothing but right return stroke. Right, this is next point. Divide the angular displacement of the cam during rising and lowering of the valve into the same number of equal even parts as in displacement diagram. What you are done in displacement diagram, you are done right, divided 6 equal parts. The same procedure you can follow here. Next point, from points 1, 2, 3, etc. and 0 dash, 1 dash, 2 dash, 3 dash, like and so on the prime circle, draw tangent to the opposite circle. Right. What about seventh point, set of 1B, 2C, 3D, etc. equal to displacement as measured from the displacement diagram. By joining the points A, B, C, and so on, M and P with smooth curve, you get a pitch curve. Now ABC extra is the center, draw circles radius to say radius of rollers. Finally, join the bottom of the circles with a smooth curve. This is the rough profile of the cam, right. By using this procedure, we get this type of which one diagram is came. This is the acceleration diagram, right. Clear, I think. Right, what that fellow means, maximum acceleration of the valve rod is need at the time. You know that angular velocity of the camshaft W is equal to 2 pi n by 60. Here n value, you know, by using this one we get W value. We also know maximum velocity of the valve rod to raise valve. At the time you can use formula that outstroke of that one velocity W pi Ws by 2 theta naught. You know W value, S value, and theta naught value, you can find that one. and maximum velocity of valve rod to lower the valve at the time 5 ws by 2 theta r in return stroke. You can find that one. The velocity of diagram for one complete revolution of the cams is shown in figure. We know that maximum acceleration of the rod raise the valve is acceleration means outward stroke theta naught is equal to a naught is equal to pi square w square is by 2 theta naught square. All values you can calculate by using this formula. You get a 6.13 meters per second square, and maximum acceleration of the valve rod to lower the value at the time ar, that is equal pi square w square by 8s by 2 theta r square. Here we can substitute all values. At last you get 24.67 meter per second square. The acceleration diagram for one complete revolution of the cam as shown in figure. By using get finally acceleration of outstroke 6.13 meters per second square, and AR means acceleration at return stroke, that is 24.67 will come. Right, this is the calculation of cam. Up to this your problems are practiced by this manner. You can practice all problems. Clear?